So, good evening, everyone. Our topic is applications of industrial robotics, presented by ROHITH.S and INGARAN. So, now let's look at the poster. By looking at the poster, you can see that the global market of industrial robotics of 2025 is $214 billion, and average uptime rate is 99.7 percentage. Its repeat accuracy is 0.02 mm. Degrees of freedom include 6 DOF. Now, let's look at the key application domains of industrial robotics. So, there are six domains majorly. The first domain is welding and fabrication. The second domain is precision assembly. The third domain is quality inspection. And the fourth domain is logistics and warehouse. The fifth domain include collaborative robotics. The sixth domain is painting and coating. So the first domain says that welding and fabrication, robot arc and spot welding with micron precision reduces the defects by 90% and eliminating human hazard exposure. So the second domain is precision assembly, high speed electron and mechanical components assembly using track sensing robotic manipulators with sub mm accuracy. The third domain is quality inspection, machine vision system with 3D scanning defects, surface defects, and dimensional errors and micro cracks production speed. So the fourth domain is logistics and warehouses. AMR and AGV autonomously transport goods, manage inventory, and optimize warehouses through 24 into 7 without any error. So the fifth domain is collaborative robotics. So collaborative robotics works safely alongside humans using force torque, sensing shared workspaces, and ISO compliant safety protocols. And finally, the sixth domain is that painting and coating. Robot spray painting delivers uniform coating thickness and eliminates VOC exposure and achieves zero overspray efficiency.
We see about industrial robot operation cycle. First one is sense. This is initial step where the robot preces its surrounding using various sensors. What happens? What 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 happens? The robot uses cameras, vision systems, and sensor to identify the location and o- orientation of the object it needs to work on. It collects this information as a raw data. Second one is plan. Once the data is collected, the robot's brain decide how to move. What happens? The system performs motion planning to calculate the most efficient and accurate path to the target while ensuring a collision-free trajectory. Next one is execute. This is action phase where the robot physically moves based on the plan. What happens? The robot drivers and mechanical giants move with high precision to perform the assigned task, such as picking up on a part or welding a joint. Next one is verify. After the movement, the robot confirms whether the task was completed successfully. What happens? Using vision sensor and force feedback sensing pressure, the robot checks if the object is in the right place or if the work meets the required quality standards. Last one is adapt. This is an advanced stage where the robots learn and improve from this experience. What happens? Using machine learning, the robot analyzes any errors on environmental changes. It then adjusts its future behavior to avoid this mistake, making the process smarter and more efficient over time.